Hi everyone, so welcome back to my channel Mathematical Swati 3226. So in this particular video, I am basically going to cover some selected NCERT questions from the topic inverse trigonometric function. So these questions are also, taken from exam idea. Like I remember when I was in class 12, I used to refer, this particular book exam idea a lot during my practice time. So yes, this is what I'm sharing with all of you guys. So yes, let's get started with the video. And these all are NCERT questions. If you have, if you want to know from where I'm, bringing all these questions. So let's start with the first question. And the first question is, we need to simply simplify this cos inverse root over 3 upon 2. This is the first question, and we need to simplify this. So this is basically very simple because we just need to write down this as cos inverse. We know that the value of cos pi by 6. What is the meaning of pi by 6 here? Pi, the value of pi here is 180. So 180 upon 6 is 30. So that means cos 30, we know that the value is root 3 by 2. So using this value, we can write down at the place of root 3 by 2 cos pi by 6. Now there is another formula, and that is if we have cos inverse cos theta. So cos inverse cos theta is going to be theta. Where what is the range of theta? Theta range is in between 0 to pi, where both 0 and pi are included. So cos inverse cos theta is theta. So here cos inverse cos theta. Theta is pi by 6. So using this formula, it will simply become the theta, which is pi by 6, and that's the answer. It was that simple. Now let's go to the next question. In this question, again, we need to simply simplify this, or in the other words, I can also say that we need to find the principal value of tan inverse minus root 3. So let's simplify this. So here we can write down this as, there is one thing that we know, that tan inverse minus theta can be written as minus tan inverse theta. Okay, so using this formula, I can write down this as minus tan inverse root 3. Now this I can write down as minus tan inverse, as it is, we know that the value of tan 60 is root 3. That means tan pi by 3. The value of tan pi by 3 is root 3. So instead of root 3, I can write down tan pi by 3 using the formula. And this is tan pi by 3. Now there is another thing, that is, if we have tan inverse tan theta, the value is going to be theta only, where the range of theta is, tan inverse tan theta is theta, where the range of theta is in between minus pi by 2 to pi by 2, where both minus pi by 2 and pi by 2 are not included. That is why open bracket. So using this formula, it will become theta. So it is minus pi by 3. See, this is also like 1 minute solution. Now let's go to the next question. In the next question, we need to write down the following function that I'm going to write down in its simplest form. Remember, all these questions are selected NCERT questions, and these questions are very, very important. So make sure you're watching this video properly and understanding all the questions step by step. So tan inverse 1 minus cos x, root over 1 minus cos x upon 1 plus cos x, where the range of x is given, that is 0 to pi. So let's start with the solution. So here what I'm going to do, I'm simply going to write down tan inverse as it is. And there I'm going to use a formula. And the formula is, we know that 1 minus cos 2x is 2 sine square x, right? But here I don't have 1 minus cos 2x. In the question, I just have 1 minus cos x. So here what I'll do, I'll divide this by 2 so that I'll get 2 to cancel. So cos x only. But if you are doing here, you have to do the same thing here as well. So now this will become 1 minus cos x, because 2 got cancelled. And this is 2 sine square x by 2. So I have made this formula. So this will become 2 sine square x by 2. Remember, this is inside the root. Upon 1 plus cos x. Similarly, we have 1 plus cos 2x is 2 cos square x by 2. Sorry, 2 cos square x. So therefore, 1 plus cos x will become 2 cos square x by 2. So using that formula, this will become 2 cos square x by 2. Now clearly root will get cancelled. So I'm getting tan inverse. Inside the root, I have sine square x by 2 upon cos square x by 2. We all know that sine theta upon cos theta. Let me change the color. We know that, 1 second. Yes. So yeah, we know that sine theta upon cos theta is tan theta, right? So using this formula, clearly here we have sine square x by 2 upon cos square x by 2. So that will become tan square x by 2, right? Now this I can write down as tan inverse. I can write down this tan square x by 2 as tan x by 2 whole square. It is same as tan square x by 2. Clearly here the square and root will get cancelled. So I'm getting tan inverse tan x by 2. Now there is a formula that I have already covered, and that is tan inverse tan theta is theta. So therefore, using that formula, it will simply become x by 2, and that's the simplified form. And we are done. So in the next question, again, we need to simplify this function, and this is question number 4. So in this, we have to simply do tan inverse cos x minus sin x upon cos x plus sin x, where the range of x is minus pi by 4 to 3 pi by 4. This is the question, and we need to simply simplify this. Okay, so let's start with the solution. Here what I'm going to do, I'm going to divide this bracket thing that is in the numerator and denominator. I'm going to divide it by cos x. So dividing the numerator, the short form is like this, and denominator by cos x. There is an intention to do that, so you will understand why I am doing this. So tan inverse, if you're dividing the numerator and denominator by cos x, so cos x upon cos x in the numerator is 1 minus sin x upon cos x. We know that sin x upon cos x is tan x, so it is 1 minus tan x. Upon, here we have cos x upon cos x, so 1, and sin x upon cos x, that is tan x. So I am getting tan inverse 1 minus tan x upon 1 plus tan x. Now in this particular step, I am going to substitute the value of 1. That is, we know that the value of tan pi by 4, that is 45. Pi is 180, so 180 divided by 4 is 45. So tan pi by 4 value is 1. So at the place of 1, I can write down this as tan pi by 4. And then this will become minus tan x as it is. Upon, this is again tan pi by 4. And this I can write down as plus tan x. Now here, at the place of tan x, if I multiply by 1, there is no issue, because 1 times tan x is tan x only. But that is going to be very helpful for me, because I have multiplied it by 4. So tan pi by 4 as it is minus tan x as it is. Now here, instead of like this one, I can just keep it as 1 only instead of writing as tan pi by 4, because actually it is going to give me a formula. Okay, so this is 1 plus, here I have multiplied this tan x by 1, and at the place of this one, I can substitute tan pi by 4. And this is tan x as it is. Okay, so now this is in the formula. So there is a formula that we know, and that is tan A minus tan B upon 1 plus tan A tan B. This has a formula, and it is tan A minus B. So you can see that here we are having the formula only, the RHS that you can see over here. It is in this form only, tan A minus tan B upon 1 plus tan A tan B. So what is the formula? It is tan A minus B. So using this formula, clearly we can write down this as tan inverse as it is, and here tan A minus B. A is pi by 4 and B is of course x. Now there is a formula that we know that tan inverse tan theta is theta. So using that formula, it will simply become theta. And at the place of theta, we have pi by 4 minus x. So therefore, the answer is pi by 4 minus x. And we are done with this question as well. Let's go to the fifth question. So in the fifth question, we simply need to find out the value of tan 1 upon 2 sine inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. Yes, that is it. So I can just put it like this in the bracket and then this in bracket and then the bracket closed. So we simply need to simplify this, as I said. So now let me change the color. And yeah, this one. So this we can simply write down as tan 1 by 2 as it is. Now at the place of the sine inverse 2x upon 1 plus x square, I can use a formula, and the formula is 2 tan inverse x. 2 tan inverse x has a direct formula in terms of sine, that is sine inverse 2x upon 1 plus x square. So I can directly use this formula. So at the place of sine inverse 2x upon 1 plus x square, I can write down 2 tan inverse x plus cos inverse 1 minus y square upon 1 plus y square. This also has a formula, and that is 2 tan inverse y. 2 tan inverse y has a formula, cos inverse 1 minus y square upon 1 plus y square, right? These are the formulas. So let me write down the formulas inside this cloud. Okay, so now we have 2 tan inverse x, and this is by using the formula 2 tan inverse y, right? Now what I can do here, I can take this 2 common, because here also I have 2, here also I have 2. So if I take this 2 common, this 2 will come here multiplied by this half, and then inside I have tan inverse x plus tan inverse y. Clearly this 2 and this 2 will get cancelled. So what I'm getting, I'm getting tan of tan inverse x plus tan inverse y. Now we can use a direct formula here, and that is of tan inverse x plus tan inverse y, which I have already written above, and that is tan inverse. It is like basically earlier formula was tan inverse x minus tan inverse y. This is tan inverse x plus tan inverse y. So simply the formula is going to be tan inverse x plus y upon 1 minus xy. So using this formula, clearly this will become tan, and at the place of this I can write down tan inverse using the formula x plus y upon 1 minus xy. Now we know that tan inverse tan theta is theta. So here at the place of theta we have this. So tan inverse tan of tan inverse theta is theta only. So that is going to be simply x plus y upon 1 minus xy. That is our theta. And this is the answer. Okay. So we are done with the fifth question as well. Now we can go to the sixth question. So in the sixth question, we need to prove something. So what do we need to prove? We need to prove tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8 equals pi by 4. So this is what we need to prove. Whenever we come across any proof question, we simply think of that, let's prove LHS is equal to RHS. So this is what I'm going to do here on the LHS. The left hand side, I have tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8. So what I'm going to do is I'm going to put this in bracket and this in bracket. You can do this in your first step. Okay, I'm just doing it directly in the question. So let's start. So I have tan inverse x plus tan inverse y. We know that tan inverse x plus tan inverse y, there is a formula. So I'm writing the formula here only, because I have already written it before. So I'm just repeating it. So tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. So I'm going to use this formula. Right? So yes, using this formula, clearly this will become tan inverse x plus y, that means 1 upon 5 plus 1 upon 7 upon 1 minus xy. That means 1 minus 1 upon 5 times 1 upon 7. That is 1 upon 35, right? And then at the place of this tan inverse 3 plus tan inverse 1 upon 8, again using the formula, it will become tan inverse x plus y, that is 1 upon 3 plus 1 upon 8, upon 1 minus xy, that means 1 upon 3 times 1 upon 8, that is 1 upon 24. Now simply this will become tan inverse. If I take LCM in the numerator, it is 35. And this will become 5 times 7, 35, 7 times 5, 35. So 5 times 1 is 5. Upon, if you simplify this, 35 times 1 is 35, 35 minus 1 is 4 is 1 is 34. So 34 upon 35. Okay. And now I have here tan inverse. Here if I take LCM, this will become 24. 3 times 8 is 24. 8 times 3 is 24. So 3. And in the denominator, of course, 24 times 1 is 24, minus 1 is 23. So 23 upon 24. Okay, remember we need to prove pi by 4 because on the RHS we have pi by 4. So here what I'm going to cancel, I'm going to cancel this 35, 35. I'm going to cancel this 24, 24. So what are we getting? We are getting tan inverse 7 plus 5 is 12. So that is 12 upon 34. And then here I'm getting tan inverse 8 plus 3, that is 11 upon 23. Now again you can see that we are in that form, that is tan inverse x plus tan inverse y. So again using the formula, it will become tan inverse x plus y, that is 12 upon 34 plus 11 upon 23 upon 1 minus x into y. That means 12 times 11 and here 34 times 23. Okay. So we can simplify this. You just need to take LCM here. So tan inverse, okay. I'll just make it a little smaller. Yeah. Okay, it's too small, but anyway, we can go ahead with this. So tan inverse and yeah. So if you take LCM here, you just need to multiply 34 and 23, and 34 times 23. Like if you simplify, it will become like, okay, I can just do here something. And what I can do is, if I simplify this, yeah, that would be great if I simplify my expression. So it will become tan inverse 12 upon 35. It is, 6 times, 2 times 6 is 12 and 2 times 17 is 34. So it is 6 upon 17. And this we can simplify it further. So 11 upon 23 only. And this will become 1 minus. Again, here it will become 6 times 11. And this is 17 because I can simplify this 17 and 23. Now, if you simplify this further, it is tan inverse. If you take LCM here, so it is 17 times 23, whatever it is. And then, of course, 6 times 23 in the numerator plus 23 is here, 23 is here. So 11 times 17. And in the denominator, we have 17 times 23 minus 6 times 11, that is 66. And then upon 17 times 23, right? Now, clearly, I can cancel this and this, right? So yeah, you can cancel this and this. So what are we getting? We are getting tan inverse. If you simplify this, 6 times 23 plus 11 times 17, the answer that you're going to get is 325. Same in the denominator. 17 times 23 minus 66, if you simplify, you will be getting 325 only. So of course, 325 will get cancelled. So we are getting tan inverse 1. Now we know that the value of tan pi by 4 is 1. So at the place of 1, we can replace it by tan pi by 4. And now by using the formula tan inverse tan theta is theta, we are getting pi by 4. And do you remember that this is nothing but your RHS, hence proved. That's the best thing to write in maths, that here you got the proof. Okay, so we are done with the, one second. So we are done with the, something happened. Anyway, so we're done with the 6th question. Now let's go to the 7th question. Okay. So in the 7th question, we need to again prove. So we need to prove tan inverse root x equals 1 upon 2 cos inverse 1 minus x upon 1 plus x, where the range of x is given from 0 to 1. So again, as I have said already, whenever you come across any proof question, the first thing that you should get is you can, prove it by doing LHS, RHS. But in this case, I'm going to simplify this. I'm going to take this LHS, that is tan inverse root x, as theta. So from here, what is the value of root x? The value of root x is tan theta, right? How? Because if I take tan on both the sides, so this theta will become tan theta, and this will become tan of tan inverse theta. So tan of tan inverse theta is just theta. So at the place of theta, we have root x, it is root x. So root x equals theta, right? Now, let us write down this time the RHS, okay? So on the RHS, we have half cos inverse 1 minus x upon 1 plus x. So sometimes we also prove, by taking the RHS and reaching to LHS. So here I'm doing the same thing. Now in this root x equals tan theta, if I do square on both the sides, so square and root will get cancelled, so it will be just x, and tan theta square will become tan square theta. So now in this I can write on half cos inverse. At the place of x, I can write on 1 minus tan square theta, and at the place of x in the denominator, it will become 1 plus tan square theta. Now there is a formula that we know, and that is 1 minus, I can write it here, 1 minus tan square theta upon 1 plus tan square theta. This has a formula cos 2 theta. Okay. So using this formula, clearly this will become half cos inverse, and this formula is cos 2 theta. Now we know that cos inverse cos theta is theta only. So this will become half into 2 theta, right? 2 will get cancelled. So what are we getting? We are getting just theta. But what is theta from here? Theta from here is tan inverse root x. So therefore we got tan inverse root x, which is nothing but our LHS. So we started from RHS and we have reached to LHS. That means, hence, proved. We have proved it. All right, so now we are done with the 7th question. We can go to the 8th question now. So in the 8th question, we need to prove once again. So it is cot inverse. Inside bracket, I have root over 1 plus sin x plus root over 1 minus sin x. And then upon, we have root over 1 plus sin x again, and then minus root over 1 minus sin x. So we need to prove that this is equal to x by 2, where the range of x is given from 0 to pi by 4. Now this question has come many a times in the board exam. So I can see basically that this question has come into 2011, 2014, 2009, 2016, 2019. So maybe next year it may come once again. So yes, let's understand this properly. So here what I'm going to do, I'm going to write down cot inverse as it is. I'm going to write down at the place of 1 cos square x by 2 plus sine square x by 2. Why? Because we know that cos square theta plus sine square theta is 1. So cos square x plus sine square x is also 1. So cos square x by 2 plus sine square x by 2 is also going to be 1 only, right? Remember, it is still inside the root. And then plus at the place of this sine x, there is a formula that I'm going to use. We know that sine 2 theta is, that means sine 2x is 2 sine x cos x. So if sine 2x is 2 sine x cos x, so what is the value of sine x? It will become, that means I've divided this by 2. So I have to divide this also by 2, this also by 2. So therefore the formula is 2 sine x by 2 cos x by 2. So using this formula, this will become 2 sine x by 2 cos x by 2. Okay. And then plus the same thing I'm going to do here. Okay. It's just there will be a minus sign. Otherwise, I'm going to repeat the same step here. Here I'm going to write on cos square x by 2 plus sine square x by 2 minus this 2 sine x by 2 cos x by 2 for this sine x. So yeah, the same thing. I'm not writing it because it will take a lot of space. And then upon, we have here Again, the same thing, you can see it's just the minus sign will come here, and the same thing will come in the denominator as well. Cos square x by 2 plus sin square x by 2 plus 2 sin x by 2. Here the sign is also same. And here again the same thing, which is inside the square root. The yellow thing is the same thing that I have written here. Okay, so yeah. And this will become again the same thing. Sin square x by 2 plus cos square x by 2, and then minus 2 sin x by 2 sin x by 2 cos x by 2. So I'm just not repeating it. Okay. Now this will become cot inverse, and you know that this is in the formula. Okay, and the formula is a square plus b square plus 2ab. You know that this is nothing but a plus b whole square formula. So a is cos x by 2, b is sin x by 2, and then this has whole square. So whole square plus. Here again we have a formula only, because it is cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 cos x by 2. This is in the formula of a minus b whole square. So this will become cos x by 2 minus sin x by 2, and this has a whole square. And in the denominator, we have the same thing, that is cos x by 2 plus sin x by 2. And then this has a whole square with minus sign, and then again the same thing, that is cos x by 2 minus sin x by 2, and then this has a whole square. All right. Okay. So now clearly you can see the square and root will get cancelled. So we will just get cot inverse. The square and root will get cancelled. So inside the bracket, we just have cos x by 2 plus sin x by 2 plus, here also the square and root will get cancelled. So we are getting cos x by 2 minus sin x by 2. All right. And then we have in the denominator upon. This is again square and root will get cancelled. So cos x by 2 plus sin x by 2 minus cos x by 2, and then minus times minus is plus. So this will become plus sin x by 2. Clearly, you can notice here that this sin x by 2 and this minus sin x by 2 will get cancelled. This cos x by 2 and this minus cos x by 2 will get cancelled. So what are we getting? We are simply getting cot inverse. Here we have cos x by 2 plus cos x by 2, that is 2 cos x by 2. And in the denominator, we have sin x by 2 plus sin x by 2, that is 2 sin x by 2. Clearly, this 2 will get cancelled. So we're getting cot inverse cos x by 2 upon sin x by 2. We know that cos theta upon sin theta is cot theta. So using this formula, this will become cot x by 2. And we know that cot inverse cot theta is theta. So therefore, this will simply become x by 2. And this is nothing but our RHS. Hence, proved. Okay, so we are done with this question as well. Now we can go to the 9th question. We have only 10. So yeah. In the 9th question, again, we need to prove only. So we need to prove tan inverse. Inside the bracket, we have 1 plus x minus root over 1 minus x. And then upon, we have root over 1 plus x plus root over 1 minus x. We need to simplify this, and we need to bring pi by 4 minus 1 upon 2 cos inverse x. Okay. So let's start with the proof. So of course, this is a proof. So I'm going to do the same thing. I'm going to start with the LHS. So in the LHS, I have tan inverse and I have this expression. I'm going to rationalize this expression. I hope you know what is the meaning of rationalization. I'm going to just tell you what is the meaning of rationalization. Rationalization means writing the same term first as it is. So I'm just doing that only. And then you need to multiply this by whatever is given in the denominator. So that is root over 1 plus x, and then root over 1 minus x with the opposite sign. So if here it is plus, this will become minus, and then divide by the same thing. So root over 1 plus x minus root over 1 minus x. This is nothing but called rationalization. Now this will become tan inverse. Now you can see that in the numerator, we have a minus b into a minus b. We know that a minus b into a minus b is a minus b whole square, because here this is a, here this is a, here this is b, here this is b. So we can clearly write down this as a minus b whole square. And in the denominator, we are having a little different form, and that is we are having a plus b into a minus b. We know that there is a formula for a plus b into a minus b, and that is a square minus b square. So this will become root over 1 plus x square minus b square, that is root over 1 minus x whole square. All right, so now we can write down this as tan inverse. So if you simplify the numerator, a minus b whole square, that is a square, that means root over 1 plus x whole square, plus b square, that means root over 1 minus x whole square, minus 2ab. So minus 2 times root over 1 plus x times root over 1 minus x. And then upon, we have root over 1 plus x whole square. So root and square will get cancelled. So we're getting just 1 plus x. Minus, here also square and root will get cancelled. So we're getting 1 minus times minus is plus x. Now clearly this 1 and minus 1 will get cancelled, right? And here the square and root will get cancelled. The square and root will get cancelled. So we are getting tan inverse. In the numerator, we have 1 plus x plus 1 minus x. So this x minus x will get cancelled. So 1 plus 1 is 2. Here we have 2 only. Here we can write down this as inside the root only, and then 1 plus x times 1 minus x. This is a property of a root, okay? Upon x plus x is 2x. So now what we can do here, I'll take 2, of course, common from the numerator. So if I take that 2 common, it will become tan inverse 2 times 1 minus root over. Can you see that this is into the form of a plus b into a minus b? So this has a formula a square minus b square. So 1 square, that is 1, minus b square, that is x square. And upon 2x as it is. Now clearly this 2 and 2 will get cancelled. So what are we getting? We are getting tan inverse. This is 1 minus root over 1 minus x square upon x. But still we have not reached to the end, because here we are going to substitute something. So I'm going to put here at the place of x sine theta. Remember, on the RHS we have pi by 4 minus 1 upon 2 cos inverse x. We are not we have not got that particular expression yet, so we need to simplify it further. So now this will become tan inverse 1 minus root over 1 minus x square. X is sine theta, so this will become 1 minus sine square theta. And in the denominator, we just have sine theta only. Now this we can write down as tan inverse. And then this is 1 minus root over 1 minus sine square theta, that is cos square theta. Why? Because we know that 1 minus sine square theta has a formula cos square theta. And how this has come? By using the formula cos square theta plus sine square theta as 1, and by shifting cos square theta to the other side and bringing sine square theta to the other side. Or I can say keeping a cos square theta on the same side and shifting sine square theta to the side of 1, we are getting this formula. And this, of course, upon sine theta as it is. Now this will become tan inverse 1 minus, I can write down this cos square theta as cos theta whole square. So square and root will get cancelled. So it is just cos theta. And then in the denominator, we have sine theta. Now this will become tan inverse. There is a formula that we know for 1 minus cos 2 theta. So I'm going to write down here. We know that 1 minus cos 2 theta is 2 sine square theta, right? So 1 minus cos 2 theta is 2 sine square theta. So what is the formula of 1 minus cos theta? That means if you divide this by 2, it will become theta. You have to do the same here. So using this formula, we are getting 1 minus cos theta as 2 sine square theta by 2. So this will become 2 sine square theta by 2. In the denominator, we have just sine theta. But here also, I'm going to use a formula that is sine 2 theta. We know that 2 sine theta cos theta. This is a formula. From this, I want sine theta only. So I'm going to divide this by 2. So this will also get divided by 2. This will also get divided by 2. And now this sine 2 theta by 2 is nothing but sine theta only. So we are getting the formula 2 sine theta by 2 cos theta by 2. Now clearly here this 2 and this 2 will get cancelled. The sine theta by 2 with the square will get cancelled. So what are we getting? We are getting tan inverse only sine theta by 2 in the numerator, and in the denominator we are getting cos theta by 2. All right. Now we know that sine theta upon cos theta is tan theta only. So this will become tan theta by 2. Now we know that tan inverse tan theta is theta. So therefore this will simply become like tan inverse tan theta is theta. So I can write down this as theta by 2. But at the place of theta, we have theta by 2. Now this I can write down as half into theta. Now, do you remember at the place of theta, like we had basically substituted this theta with something. Let's check. So we had substituted x equals sine theta. So what is the value of theta from this? The value of theta from this is sine inverse x, right? So therefore, I can write down at the place of theta sine inverse x. Second. Oh, okay. All right. So I think I'm here. Okay, so this is half into, at the place of theta, I can write down just sine inverse x. But still we have not reached to the RHS, because on the RHS we had this expression, pi by 4 minus half cos inverse x. We have not reached to this. We can reach to this. This is very simple. We know that there is a formula, and that is sine inverse x plus cos inverse x has a formula pi by 2. So from here, what is the value of sine inverse x? The value of sine inverse x will become pi by 2 minus cos inverse x, right? So I can write down this as half times at the place of sine inverse x pi by 2 minus cos inverse x. And now if you simplify this, half into pi by 2 is pi by 4, and then half into cos inverse x is half cos inverse x. And you can see that this is nothing but your RHS, hence proved. So we are done with the 9th question, and now we are heading towards the last question of this video, and that is the 10th question. So in the 10th question, we simply need to solve this. Solve this meaning we need to find the value of x. So we need to solve here tan inverse 1 minus x upon 1 plus x equals half tan inverse x, where the condition for x or the range for x is given that x is strictly greater than 0. So we need to simplify this. So what we can do here, we can simply write down this as the question first, tan inverse 1 minus x upon 1 plus x as it is. Now from this, I'm just shifting this 2 to the other side because it is getting divided here, so it will get multiplied. So 2 will get multiplied here, and this tan inverse x as it is, right? Now there is a formula that we know for 2 tan inverse x, and the formula for 2 tan inverse x is tan inverse 2x upon 1 minus x squared. So using this formula, this will become tan inverse 2x. So 2 times, what is the value of x? The value of x is this. This is entire x only. So this will become 2 times x. That means 2 times 1 minus x upon 1 plus x. And then upon 1 minus x squared. That means 1 minus x upon 1 plus x. This is whole square. Okay. And then equals tan inverse x as it is. Now this we can write down as, if you simplify this, it will become, okay, 1 second. Yes, so this will simply become tan inverse 2 times 1 minus x, right? And then we have 1 plus x, and in the denominator we have, if you simplify this, it will become 1 plus x whole square after taking LCM, and then minus 1 minus x square as it is, and then upon 1 plus x whole square as it is, right? Equals tan inverse x as it is. Now clearly here this 1 plus x with the square will get cancelled, right? So I can write down this as tan inverse 2 times 1 minus x, And this term will go in the numerator if you simplify this. So it will become 1 plus x. And in the denominator, we simply have 1 minus x square minus 1 minus x square. So if you simplify this using the formula of a plus b whole square, it is a square plus b square plus 2ab, that is 2x only. And here this will become, in bracket it is, so a square plus b square. But if you remove the bracket, the sign will get changed to minus x square and then minus 2ab. But of course, if you remove the sign, like the bracket, the sign will get reversed. So it will become plus 2x, right? And then equals tan inverse x as it is. Now clearly here 1 minus 1 will get cancelled, x square minus x square will get cancelled. So what are we getting in the denominator? We are getting just 4x. Now this will become tan inverse 2 times 1 minus x into 1 plus x. This is into the formula of a minus b into a plus b. We know that it is a square minus b square. So 1 square is 1 and b square is x square upon 4x. Clearly this 2 and 2 will get, 4 will get cancelled. This is tan inverse x as it is. And now this will become tan inverse 1 minus x square upon 2 equals tan inverse x. Now there is a formula that we know that if we have tan inverse theta equals tan inverse x, okay? So I'm just writing the formula here. That if tan inverse theta equals tan inverse x, it simply implies that theta equals x. So here this is theta and this is x. So using this formula, this implies theta equals x. That means 1 minus x square upon 2 equals x, right? And now this will simply become, this is 2x, right? Yeah. And now this will become 1 minus x square. If we do cross multiplication, 2x times x is 2x square. Now this will become 1 minus, so 1 equals 2x square as it is, shifting minus x square to the other side, so plus x square. Now this will become 1 equals 2x square plus x square is 3x square. So from here we are getting x squared equals 1 upon 3. It simply means x equals plus minus 1 upon root 3. But here minus 1 upon root 3 is not valid because we just have one condition, that is x is strictly greater than 0. So it can't be minus, like it can't be negative. So therefore the answer is x equals 1 upon root 3. This is what we wanted to find in the last question. We need to solve the following equation for x. And we are done with the video. So yes, I hope you understood each and every question that I explained in this video. If you have understood this, if you have liked my video, don't forget to share it with your friends. And yes, if you have not subscribed to my channel, guys, do subscribe to my channel and keep supporting me. Thank you so much.